In this video, we will take a look at how to find second derivatives. So when we have a function and we take the derivative of that function, we will now call that the first derivative. When we take the derivative of the first derivative, we have the second derivative. So in the first example, we have a function, and the first derivative will simply be the derivative of that function, which will be 5 times 3 is 15 x to the fourth minus 16 x cubed plus 4x. So this is now what we will call the first derivative. And we will also note that we only have one little prime mark up there. To find the second derivative, we simply take the derivative of the first derivative, and we will put two little prime marks up there. So 4 times 15 is 60 x cubed minus 3 times 16 is 48 x squared plus 4. And so this is now the second derivative. Should be noted that we could take more derivatives if we wanted to. It's not as common that we would take a third derivative, but that would simply be the derivative of the second derivative. 3 times 60 would be 180 x squared minus 2 times 48 is 96x. That would be the third derivative. And in some cases, we could take a fourth out of fifth. And sometimes you can take an infinite number of derivatives. But for the most part, we only are interested in the second derivative. So in this problem, we have an equation. So y prime will be the first derivative, which would be negative 2 times 3 is 6x squared. 5 times 2 is 10x. This is now the first derivative. The second derivative, with two little prime marks up there, would be negative 6 times 2 is negative 12x plus 10. In this case, if we wanted to do a third derivative, three little prime marks, we would simply have negative 12. And that would be the third derivative. In the next derivative, we have f of x equals e to the negative x. And so we have to use the chain rule here. F prime of x is going to be e to the negative x times the derivative of negative x, which is negative 1. That then becomes negative e to the negative x. The second derivative is the derivative of this, which would be negative e to the negative x. And the derivative of negative x, again, is negative 1, which becomes positive e to the negative x. So notice that the second derivative is the same as the original function. And if we took the third derivative, we would end up back with negative e to the negative x. And the interesting thing about this particular function is that its derivatives will go on forever and ever, and they will constantly alternate between positive and negative. In this function, we have to use the product rule because we have two different functions. We have an x and we have an e to the x. So to find the derivative, we're going to take the first derivative, that is, we're going to take the derivative of x, which is 1, times e to the x, plus x times the derivative of e to the x, which is e to the x. So this simplifies to simply e to the x plus x e to the x. And now the second derivative will be the derivative of that. And so the derivative of e to the x is e to the x. And then the derivative of this will be exactly what we just had, which would be e to the x plus x e to the x, because notice that this is exactly the same as what we started with. And now we can combine these two terms. Oh, this is the second derivative. So the second derivative would be 2e to the x. We have two of them here, plus x e to the x. So now we have something that looks a little bit different. We just want to find the second derivative. Unfortunately, we have to go through the first derivative. So the first derivative, to find that, I'm going to want to rewrite this function as x to the negative 1 plus the log of x. And so the derivative of x to the negative 1 is negative 1x to the negative 2. The derivative of the log of x is 1 over x, which is similar what we had, the same as what we started with here. And so this would be negative x to the negative 2 plus x to the negative 1. That's the first derivative. The second derivative is the derivative of that. So this will be negative 2 times negative 1 is a positive 2, x to the negative 3. And then x to the negative 1, the derivative will be the same as what we had over here, negative x to the negative 2. And so that is the second derivative. We would probably want to clean it up a little bit. 2 over x cubed minus 1 over x squared. And one more problem for this video. Let's rewrite this in a form that we can actually apply our derivative rules. This would be negative 2x to the negative 2 plus x to the negative 1/2. So that's just rewriting the original function. Now the first derivative, applying our rules, will be negative 2 times negative 2 is 4x to the negative 3. And then we're going to have a minus 1/2 x. Minus 1/2 minus 1, or 2/2, is minus 3/2 power. And then the second derivative will be the derivative of that, which is negative 3 times 4, which is negative 12, x to the negative 4. Negative 3/2 times negative 1/2 will be a positive 3/4 x. And then negative 3/2 minus 2/2 is negative 5/2. So negative 5/2 power. And then we want to rewrite this in a little bit better way. So we'll do negative 12 over x to the 4th. I'm going to leave the 3 in the numerator. The 4 is in the denominator. And we'll make this the square root of x to the 5th. And that is our second derivative.